collector to base voltage. V sub CEO is the maximum collector to emitter voltage. Using a voltage higher than the rated voltage can damage the transistor junction. Transistor packages are identified by two parameters: type number and case. The type number of a transistor is a unique identifier assigned to each type of transistor. Three different international schemes are used: JEDEC type number, European Pro-Electron type number, and Japanese type number. The Joint Electron Device Engineering Council type number is the most common. Transistor part numbers start with 2N using the JEDEC type number. For example, the 2N2222 is one of the most common transistors. This type number uses several different two-letter prefixes that identify the type of transistor. For example, a BC548 uses BC to indicate it is a small signal silicon transistor, while a BF245 uses BF to indicate it is a high-frequency silicon transistor. Japanese type numbers start with 2S. A third digit is added to specify the type of transistor. For example, a part number that starts with 2SC indicates the transistor is a high-frequency PNP transistor. Transistors are available in a wide variety of case styles divided into two categories: TO and SOT. The TO case style has 3 connection points. Its leads are designed to be inserted into a circuit board and soldered into place. Plastic TO case styles have several common variations. TO92 transistors have a small case. They can dissipate up to a few hundred milliwatts. A TO220 transistor is a power transistor package that can dissipate over 100 watts of power. A TO247 transistor is another power transistor package that can dissipate up to 250 watts. Metal TO case styles have several common variations. TO18 transistors dissipate more power than TO92 transistors, up to several hundred milliwatts. TO39 transistors can dissipate more power than the TO18 style. TO3 transistors can dissipate up to 300 watts. The SOT case style is used for surface mount transistors, which are smaller than the TO style transistors. Describe the operation of a transistor switching circuit. One of the main uses of transistors in industry is as a semiconductor switch. Semiconductors operate faster than mechanical devices and require less current. Also, because there are no moving parts, semiconductor switches are extremely reliable. The basic concept of a transistor switching circuit is that the transistor is switched between cutoff and saturation so that it is always either on or off. In switching circuits, the transistor does not operate in its linear region. Shown is a basic transistor switching circuit. In the circuit, the power source V sub BB supplies the input voltage needed for the base emitter junction to conduct. Without the proper voltage, the transistor will not operate. Base resistor R sub B provides current limiting to the base so that the transistor does not overheat. When switch PB1 is open, there is no voltage applied to the transistor's base, and therefore no base current. Without a base current, there is no output or collector current, and the transistor is said to be in cutoff. Therefore, no current flows through the load resistor. In other words, the transistor behaves like an open switch. When switch PB1 closes, a voltage is applied to the base circuit. The combination of V sub BB and R sub B is set so that the base current causes the transistor to operate in its saturation region, behaving like a closed switch. The transistor operates in its saturation region at maximum collector current. Because it is in series with the transistor, the load resistor has the same current flowing through it. Transistors can only drive a load directly if the current requirement of the load is small enough that it will not damage the transistor. If the transistor switch must control a larger current, a relay can be placed between the transistor and the load as shown. The collector current energizes the relay coil. The relay contact supplies power to the load. In this type of circuit, a resistor is also placed in series with the transistor output for current protection. Inductive loads, such as relays, create a countervoltage or CEMF when their magnetic field collapses as they are turned off. This voltage can damage a transistor. When a transistor switching circuit must control an inductive device, a diode is placed in parallel with the load to protect the transistor from the CEMF. Which regions does a transistor operate in when used as a switch? In a transistor switching circuit, when should a relay be used to control a load?